Okay, so I'll do a short demo, and then we'll break up into pairs, and I'll ask you to do it, and then we'll chat about how it went. These two resources down here are going to be useful to think about and to use when you're pairing, and this is the exercise that you'll do. You'll have all these user stories, and you'll just go through maybe one or a couple at a time. But at the moment, let's just focus on watching this demo. Note down any questions that you have as you watch me do it, as I explain things. Pause me or just shout out, like, ask questions, all the normal stuff. And again, so the point of this is just so we can get better at looking at requirements of user stories and trying to infer what our database should look like. Does that sound right? Yeah?
Yep.
Yep. Cool. So I'm switching over to the mirror board, so feel free to use your own mirror board if you want to zoom in and zoom out, or just look at mine. And I'm going to go down to here. So I'm going to leave it here and then switch to my tablet. But is this zoomed in enough, folks? If not, you can use your own.
It's okay.
Yep, it's okay.
Cool. So let's have a go at this. So we're going to look at the class, the responsibility, and the collaborators. And usually we set out a CRC card or a class responsibilities collaborator card into two parts. So let me get my pen up. And here we have the class. And here we have the responsibilities. And here we have collaborators, if there are any. Collaborators. So I'm going to look at the information on the right first. So we have a set of 4 user stories. As a customer, so I can get a bicycle. So this is very familiar. We're using back to our DocuStation domain back in to our TDD units. So I can get a bicycle. I want to withdraw a bicycle from a DocuStation. And then the second user story is so I can complete my trip. I want to dock a bicycle back at a docking station. So let's start with our first one. And our class here looks like it's going to be a docking station. Let me do this in a different color. And let's go green. And there's much room here. The docking station is our class. Its responsibilities looks like it had withdraw and dock bicycles. So it looks like the collaborator here has to be some kind of bicycle. If that's the thing that it's interacting with. And as a customer, I'll go to the next one. As a customer, so I can have the best cycling experience, I want to only get working bikes from the docking station. Okay, so this is now working bikes. So bikes need to know if they're working or not. So let's create another card. Here's going to be the bike. Here's going to be the responsibilities. And these are going to be the collaborators. So here we're going to have a bike. And here it's going to have to know whether it's working or not. There are no collaborators. All right, bike doesn't need anything. Bike is just simply responsible for knowing whether it's working or not. I want to only get working bikes from the docking station. So there's probably going to be another responsibility here to say withdraw only working bikes, maybe. We'll put it down for now. It might be included in the first responsibility just to withdraw. And the last one, so I can tell how many bikes are at each docking station. I want to get a count of the number of bikes at the docking station. So here's another responsibility. And I'm out of space. Let's just put it here. Count bikes. So again, apologies for my lovely handwriting. Calligraphy is on point today. So this is how I'm thinking about these two classes according to my set of user stories, class, responsibilities, and collaborators. Now, notice that the bike doesn't have any collaborators and the docking station has a collaborator. And this is important because we're going to use this information to create some tables in a second. The docking station needs to know about bicycles, but bike does not need to know about the docking station. Cool. Okay. Pausing for any questions or any thoughts at the moment. Everybody pretty good? You just give me a thumbs up on the Zoom thing. It's all good.
Yeah.
Yeah. Any questions? Shout them out. Be like, why do you have the green color or something? I'm not sure.
That's not my question, but I guess
yeah, go ahead.
The docking station, when you said the collaborator is the bicycle, does that mean that it needs to know about the bicycle? Or because you said conversely, your bike doesn't need to know about the docking station. So I just wanted to explore that relationship a little bit.
Yeah, exactly. So nowhere in the bike code will we ask docking station to do anything. Whereas in the docking station, we have to ask bicycle, is it working or not?
And the bicycle written with green, is that a different class than the bike?
Yeah, these are two different classes. Class docking station, class bike.
What about the bicycle written in green?
Yeah, sorry, bike is bicycle.
Okay.
Great question. Bike, I should just written bicycle, yeah. I'm going to change that because that actually is confusing. Yeah? Does that make more sense, Amy?
Of course, yeah.
Yeah, thank you, because it makes sense. Why am I using two different names? I mean the same thing. Yeah? So far, Sabir, back to your question, because it was a good question. Does that make sense?
Yeah. So the collaborator bike is actually another instance of a class then.
Yeah, exactly. Okay. Or it might not always be, but in this case it is, because we'll have like a set of instances of bicycles in our docking station. Yeah. And we'll be interacting with them, whether asking whether they're working or withdrawing or docking them.
Yeah, makes sense. Thank you.
Yeah. Cool. Cool. Okay. Sounds like so far so good. So from this information, let's have a look at creating a set of tables for this. Now, one of the reasons why we choose to use class responsibilities and collaborators is because the collaborators section is useful to help us think about how we're going to associate these tables together. And it's a bit counterintuitive. But let's have a look. So let's go with red. So let's start off with our bike first, because the bike's simpler. Actually, well, yes, not really. And let's go with our bike. That's not how I want to draw it. Let's just do it inversely. Okay, so this is going to be our bikes table. And every table should have a primary key. It's the unique identifier for each row of the table. And commonly, the vast majority of cases, you'll see ID as the primary key. ID is a special field, and usually is taken care of by the database itself to auto increment and make sure each field is unique. So we're going to have an ID column. And at the moment, is there any information that we need to know about the bicycle, whether it's working or not? So how can we represent that information in the table? Let's say we'll keep it as a field, like a Boolean field, where it's going to be true or false, and just say it's going to be a field called working, question mark. So for instance, if we had some data in this table, it could be something like ID of 1 and true. Let me zoom in. True. Sometimes you'll have it as like 1 or 0, and depending on how you set your table up, but let's keep it as true or false for the moment. Imagine we have another bit of data in here. 2 is false. So we have 2 bikes. One is working, one is not. Okay, so I'll leave it for the moment, but we're going to come back to that in a second. And here, let's try and represent our DocuStation. I'm sorry I've done this almost the opposite way around, because DocuStation on top, and I put bikes on top, but it doesn't matter. So let's put DocuStation here. Actually, I wanted it to be lowercase because it should always be lowercase. Docking stations. And as always, we have our ID. And here, I guess we can have a name for our docking station. Do we have any other information from it? No, I'm going to keep it blank for the moment. So imagine we had 2 docking stations, ID of 1, ID of 2. Okay, so now the question is, how are we going to relate them? How are we going to make sure that there's a relationship between these 2 tables? Now, commonly what you'll see when people first start thinking about IDs or how to relate them is you want to say, well, DocuStation has a bunch of bikes. So why don't we just store, for each DocuStation that we have, let's store in a column called bikes, an array of all the bikes. And this is not the way to do it, but this is quite intuitive, all right? However, storing arrays in columns is just not a good idea. And I'll show you in a second why. It means every update or every change to it, you have to constantly update one field, and it's hard to get the information out when you want it, specific information. So rather than store it like this, which is quite intuitive, as we think of DocuStation as an array of bikes, we're going to do it the other way around. And what do I mean by that? Is it's going to be, rather than say the DocuStation has information about the bikes, we're going to say the bike has information about the DocuStation. And this is when the idea of a foreign key comes in. So let me delete this. Rather than have that, we're just simply going to have docking station ID here. So if we wanted to say that both the bikes were in docking station 1, you just put 1 for both of them. And docking station number 2 is just empty. It has no blanks. So that's the slightly counterintuitive approach of using class responsibility collaborator cards, is that the collaborators doesn't show up in that table. It's the collaborator table that shows up in. So DocuStation collaborator is bike. That relationship shows up in the bike table, not the DocuStation table. Any other information like the count of the number of the bikes, I don't need to keep in the table. So commonly you might see the count stored in a database because people don't know what they're doing. But the count is a runtime function that we can count. So we can just say, get all the bikes from the docking station and sum them up. So I don't need to keep the count there. Because I already have the count here in terms of using the docking station. I have 2 bikes in the docking station. So as long as I have the right records, I can calculate that when I need to, rather than storing the number itself. Otherwise, I have to update the number and also insert bikes, if that were to be the case. That will cause problems. Okay, pausing for questions and thoughts.
If the second docking station did have to be inserted into the bike table, would it be just another column on the right?
So talk to me about what you're trying to do first. So what would that help you do?
So, for example, you said at the in the docking station table at the bottom, say we wanted to know that there is a bike in there that is working. Do we just incorporate that into the table above?
Yeah. So give me a scenario. Which docking station has which bikes?
So the second docking station, number 2, has say 2 working bikes and 1 non-working bike.
Cool. Then we have to add that in here. So we do ID 3, 2 true. This would be 2. 4 true. This would be 2. And 5 false, and that would be 2. So now docking station 2 has 2 working bikes and 1 broken bike.
Okay. Okay, I see what you mean. Yeah.
Yeah, because the docking station ID will refer to the primary key of the docking station. So here is what we call foreign key. The foreign key will always look towards the primary key, and this is the primary key, and this is the primary key. So this foreign key looks towards the docking station's primary key. And they're the same thing, right? 1 and 1 or 2 and 2.
Yeah. Okay, yeah.
Now we have to set this up, so we have to use some SQL to like establish that the docking station ID is the foreign key. But that's what we do using SQL. But this is what the table will look like. Yeah. Good question, Sylvia.
No problem. What exactly is a schema?
Cool. Good you ask, because I know it's on the list of up here on schema.
Because you've labeled it as well, schema.
Yeah. Schema. What do you think at the moment? Like, what would we give your best guess is what the schema is?
Mapping.
Not the mapping itself.
Like the sort of template of how this database is structured. So it has these tables that have these columns with these data types and restrictions, and exactly. They are linked to each other on these ID, like this ID column is referencing this ID column. Exactly,
yeah. Essentially, it's like, as you said, the template, the skeleton, what is the, if you need to set this database up elsewhere, what is the information you need to set up in the same way?
Kind of all the stuff in red is the schema.
Yeah, and purple-ish. Yeah.
Is it purple?
Kind of.
Sorry.
Red and purple, but foreign key.
On my screen.
Yeah. Sophia, does that make sense? Or was that Anastasis? I can't remember who asked that question. Schema.
I asked it. Yeah. Yeah. I think that. Yeah, that gives me an overall picture of what it is. Yeah.
Cool. Nice.
So is it a rule that the foreign key will look up the upper table?
Say it one more time.
Is it like a rule that the foreign key will always look up at the upper table?
Primary key.
Yeah.
Yes, pretty much. Yeah. Mm-hmm.
Here, obviously, it's quite a simple model, and you're creating the schema based on the bike rather than docking station. What if it gets really complex and there's many objects? How do you know what to base it on? So say, I can't think of an example for a docking station, but
well, we'll get there because I think the next example I want you to do is a little bit more complicated.
Okay.
Yeah.
It
So
always
the same thing applies.
Okay.
Is use your user stories, convert them to using class responsibility collaborators step by step, and then you use your CRC card to then inform your schema, and just go table by table, and see what works. A lot of these things you won't really know until you write some code to make it work. You realize, actually, no, I shouldn't have done this way, and you do it this way next time. But as long as you have a working understanding of it, you'll improve over time. So don't think you'll get it right, like super correct the first time. As long as we understand the process, and all these things that we're trying to do is just the process. How do we get from a user story or a set of user stories to a database schema? It doesn't have to be a perfect schema, it just has to be a working schema. Yeah. Cool. Any other thoughts and questions at the moment?
So I presume for this example and these four user stories, we could do it with one table, right? But we're just having like two tables in case, like, the docking station where to store more information than the capacity or except the name or other details.
And how do you do it in one table?
Like on the docking station ID, just to put the name of the docking station on the bikes table. Like, okay, if you were to store more details on the docking station table, then we would like, of course, we would like two tables.
Yeah.
But if you had like 1, 2, 3 user stories, could we do it in one table?
Okay, so the answer is yes, you can. The moment you won't run into any problems because the docking station table has very little information in it. And there wouldn't be too much of a problem at the moment. Now, the purpose of this exercise is you should see if you have classes, at least models that are classes, because not all classes will be models. If you're using a docking station and a bike class for your domain models, then you should be using the same tables. So there's usually a good, like we said before, there's usually a good rule of thumb that says a class will model a table. So if you start there as a good rule of thumb, you don't go wrong that often. And when we start to think of like larger applications that have lots and lots and lots of data, you want small tables with single responsibilities rather than large tables with multiple responsibilities. Because otherwise it will get very, very difficult very quickly. So same kind of thing, same kind of principles of sort of object-oriented design, you'll find, or at least like modularity, like creating modular things, is a good rule of thumb in almost all software. Really try it out, and assess this, try it out in one table, try it out in two tables, and see how it goes, because you can do both. Cool, good question. I like the question. And also, if you need to start updating things, you have everything in one table. You need to update the documentation name. You have to do that everywhere in that one table that has that name, rather than just doing one update for that documentation record in the documentation table.
Yep, noted.
And then you have to imagine that amplified when you have like thousands and millions of records in the table. Yeah, good question. Any other thoughts, questions when we look at this simple contrived example? Cool. All right, so let's it's time for you folks to do some work. Here, what I want you to do is go through the same approach. Start with your CRC cards, model the domain, and spend about 20 minutes doing it. You probably might be done sooner than this, or don't spend too much time. Do enough, like I did, pen and paper, or on Slack when you're working with each other, or on Miro. And model it first. If you want to check it, run it by me, give me a shout. And then after you've modeled it, then create your database structure. We're not going to be writing any code. It's just simply going to be a modeling this morning. So once you've mapped out from these stories your class responsibility cards, then you can go on to create your database structure, essentially just like I did. There's a couple of resources for you to have a look at, because at the moment I've only done one-to-many relationships. One documentation has many bikes, and there might be one or two more in this set of user stories. So you have 1, 2, 3, 4, 5, 6, 7, 8 user stories. Take that bit by bit. It starts off fairly straightforward, and then there are a couple of interesting things here, and we'll review it in about 40 minutes time. About half past, see where we get to. It might be quarter to. The pairs are the pairs in Slack. So Amy and Anastasis, Sabir and Ellen. And any questions about what we're going to do for the next 45 minutes? Everyone feel like they know what they're about to start doing?
Yep.
Cool. CRC cards. If you need me, run it by me. Give me a shout on Slack. Once you're on the CRC cards, really put a time limit on this for 20 minutes, see how far you get, and then start creating a domain, your table structures, and you can go back if you need to go more user stories. And let's see where we get to. Cool. All right. Let me just send this into Slack.
Yeah, that's what I was about to say. Can we have it in Slack, please?
Yeah, do. Cool. If at any point you get finished with all these things, go back and have a look at those 5 concepts on Miro board to write more definitions to. Cool. I'll be on Slack. Otherwise, I'll see you at about 11:40.
And then shall I send you a Zoom link?
Yes, please.
Okay.
Amy, I will send you the Zoom link.
Yes, please.
Ed?
Yep, what's up?
Yeah, I booked a coaching session for 12. Let's cancel it because the time that I booked it was like the time before we had the one-to-one, the pairing.
Cool. All right. No worries. Are you sure?
Yeah.
All right. No worries.
Thank you.
Cool. We now resumed the recording. Just on the minute. Questions. I'm going to start reading through them. So keep writing questions. How do you decide when a property of an object, for example, the start date of the cohort, the photo URL of the student, should be a separate object on the table with collaboration links? Good, interesting question. How do you decide with two very simple related tables, students' photos, which table should have the foreign key in it? Where can we create our diagrams and tables? Wasted so much time. Yep. How do you decide what objects to create when objects to create? When going through the user story, doesn't assist another class, so it can be responsible to avoid. Will the data type always be an integer when referencing foreign keys? Should the CRC card for a class mention the attributes that are being provided by collaborators? Cool. All right, let's get cracking because we have 8 minutes. We might stretch to 12:05. Okie doke. This one we've answered. This one's not a question. It's just a resource. Cool. So let's start with number 1. Let's just move them across. So let's start with this one. Boom. How do you decide when a property of an object, for example, the start date of a cohort, the photo URL of a student should be separate? Should be a separate object. Okay. How should we tackle this question? So let's have a table. And the start date of cohort should be separate objects. So your question is, if I can understand it, is when should you, if we have a cohorts table that has an ID and has tables, has columns, and specifically has a start date, for example, when should you have an actual start date, and when should you have like this as a foreign key to a start date table? Is that the question?
Yeah.
Cool. This is a really great question. So the reason why I think this is a good question is because it is about just trying to understand the difference between what happens in the process. Like, what are even the columns based upon? I think that's the underlying question here. And if we follow the process up above, trying to think about our domain objects, so these are all derived from the requirements, the user stories. So if we have a requirement or a bunch of user stories around how start dates need to behave, then that stands to reason that should be a table in itself, because there'll be a model with a bunch of functionality. At the moment, there is no real information in the requirements that say this needs to be its own model. And so start date is usually just a date field in the corresponding table, rather than its own object. That's usually how it gets modeled. But if the start date needed a bunch of other behavior, and I'm not even sure like what that'd be off the top of my head, maybe there's like a process that has like an owner. Someone has to own the start date, and there's like a duration of hours. There's a curriculum for the start date, like there's actual start day maybe.
Yes,
start date is the event. Something like an orientation or something like that. Maybe that would be the domain that would include that as its own object. But given that's just not what's happening here, it's just simply going to be a column of the cohorts table. And so all this information that we're talking about gets derived from the requirements. And so we use the requirements to inform us and try and keep it as simple as possible. balancing the simplicity with single responsibility. And there's never like a super real like right answer to these things. There's always going to be some trade-off. So don't worry too much if you end up creating more tables than you think you have. You will over time get more of a sense of this. The rules of thumb are if you see it as nouns and verbs in your user stories, and it's likely there's going to be some table relationship between the noun and the table. There are other things like created at timestamps that you can just add automatically, that the database handles for you. So you can have like an updated at time field, like anytime there's an update statement, it just logs the last update time or the created at, and these are all properties of tables rather than their own table. And the other part of this question, which is maybe related to some of the other ones, is anything that you can calculate at runtime, keep it at runtime. And that means like if you can have a method of a class to calculate something. So for example, in this one, I think the average rating of the students, if you got that far, doesn't need to be its own table because you already have the ratings table. So anything that can be calculated at runtime, keep it that way. Yeah. In the same way where it's like this trade-off between like keep as little state as possible, calculate if you can, calculate it when you need to, rather than keep storing everything. I think I had a question there, sorry.
No, saying count of bytes would be the same sort of rationale, right?
Exactly.
The database just stores effectively the raw data. It doesn't.
Exactly.
Your code processes it.
Exactly. Where possible, exactly. It stores as little data as possible, but needs to, yeah. So I think that was a little bit similar to this red card here. How you decide what objects to create when going through the user stories as in say another class, or can it be responsibility of an object that already exists? This is related in the same way. I think the orange card is talking about the sort of database schema, and this is talking about the domain model. And it's just use the requirements, use the nouns and verbs, and try it out, thinking about single responsibility. Is there a specific? I think it's a sphere again. What was the? Do you have a specific example in mind for that question?
Yeah. So when Ellen and I were pairing, we were discussing similar to what you've already described about the start date and demo date, but we were discussing whether that should have its own class. Or whether it should be just a responsibility, but we decided to just put it within the cohort class. So we didn't create another,
Mm-hmm. And there's this idea called database normalization. There's a fancy word, but essentially it's what we've just been doing, which is trying to find ways to make sure every piece of data is just unique. And not multiple times, like remove redundancy. So if you see things cropping up multiple times, like the same start date, loads of places, it might be that that's enough of a reason to extract it out and have its own table. Mm-hmm. Because otherwise you might need to keep updating loads of times if you need to change the start date en masse for a bunch of things. So where possible, and same thing, if you see like in your Ruby code, a bunch of code that's like you repeated in a lot of places, you want to extract it and form a method around it and use that. So the same kind of thing happens in software as a general rule. If you see repetition, extract it and use a method or use a technique to dry it out. Same thing happens with databases and tables. And the technique we go there is extract it as a table. So yeah, look at the requirements, think about the requirements. Does it have behavior? Does it have properties that you need? Are you going to be using it a lot? And those are things I'd be thinking about. Really, really good questions, folks. Next question. So far, so good? Yeah. Cool. Next question. Will the data type always be an integer when referencing foreign keys? So I'm going to rephrase or reimagine this question. And the question I'm going to say is, what should the data type be for foreign keys? Okay, because that question means we're thinking about what is the foreign key referencing? The foreign key is always going to reference the primary key of another table. Yeah, let's go back up to this table up here. And I guess I should be sharing my screen. The folks on who watch this recording will have no idea what I'm talking about. That's fine. If I look at the previous example I did during the demo, the foreign key references the primary key of the docking stations. Can you see that in the bike table? Foreign key references the docking station primary key. Yeah.
Yeah.
Which means that foreign key should always just have the same data type as the primary key. So at the moment, the most common primary key that we know of is the ID, which is an integer. It's a special kind of integer, not just an integer. Let's ignore it for a moment. But sometimes you might want to have a strict, unique constraint on email address, for example. And so you want to have like a primary key or even a second primary key that's a text field or a different kind of thing. And then your foreign key will have the same data type. So the best way to think about the data types for a foreign key is just whatever is the primary key. And by the vast majority of cases, the primary key will be the ID field. Does that make sense, Sabir?
Yep, thank you.
Good question. That was a really good question. Cool. Should the CRC card for a class mention the attributes that are being provided by collaborators? For example, the CRC for students, should it reference photo URL or cohort? Okay, let me have a look at this example. So I'm going to share my screen now because that is where it makes sense. So if those folks who are watching the recording, let's blue P to this stuff. Look at that, boom. And so the question is, go quick look back, boom. Should the card for a class mention the attributes they're being? So for example, for students, should it reference photo URL or cohort? Oops, go away. This is one suggested implementation, and this one only references the cohort ID, and lets the cohort ID take care of everything, but does have the photo URL. Because the photo URL isn't its own table, it's just a string. So in answer to your question, it doesn't.
The CRC card, the kind of preliminary step, wouldn't talk about the fact that a student has a cohort.
The student belongs to a cohort. So the student, no. Because the student might belong to a bunch of other places, might belong to a year, it might belong to a geographic location. But the cohort will say it has many students.
But in a way, like the very fact there's a column of the cohort ID on the student table, the cohort is a property of the student.
Yep.
And it is something that you may want to ask for. Like you might want to have a cohort method on a student object.
Yeah. Yeah. And commonly you'll be able to use we'll talk about that next week. So in this example that we did during the demo, notice the bike, we haven't mentioned what its collaborator is. Now, this is because bikes don't know about their parents, but parents know about their children. But when we think about relationships, it's important because, well, it's tricky, as I said, because it's counterintuitive, right? So this here would mean that documentation has many relationships. Also known as like one-to-many. And the converse of that is bike belongs to. But we don't necessarily have to put it straight here in this CRC card. You can if you want to. Again, tools are for yourself. So if you feel like it helps you make sense of it to couple these two things together, absolutely. Belongs to, in this case, in this example, it belongs to documentation. But usually this information is as a result of here. So we use the fact that documentation collaborates with the bike to say that documentation has made bikes and bike belongs to documentation.
And if you had a user story that said, as a administrator, so I know where a bike is, I want to know the name of the docking station it's at. Like at that point, is that the point where you go, well, bike now has a responsibility of like, and in this case, a responsibility not for like the storing the state, but for responding to a query of like docking station. And so then it would show in the responsibilities, even though the bike itself is not responsible for knowing, like it's not responsible for
that information is still part of this card here, not here. I know it's counterintuitive.
So in a CRC card, you wouldn't necessarily mention all the methods that your bike class would have.
No, because those aren't the responsibilities of the bike itself. They're going to be the whatever.
They're the interface with the bike, not its responsibilities.
Yeah, and so we call that an ORM, like an object relational map that takes care of that. At the moment, we've been writing our own using the PG gem directly. And so you could add a method saying for each instance of a bike, you should be able to have a docking station method that returns to it that instance. It goes into the table and returns that instance. So you can add those yourself, and when we use third-party ORMs, that all comes with it. So if it helps make sense of it in the interim, feel free to use a CRC card to have this belongs to documentation. Again, tools are for you to use. But if you have more collaborators, say, for example, the bike is used in different objects, you're going to start adding loads of things in this space here, which again is not the point. We should be adding them in each class that collaborates with bike. We should add them as collaborators on that card. And so the information for that relationship is here, even though the inverse happens in the table, where we use the IDs as foreign keys. Yeah. Now, again, if you feel like it makes more sense, just add all the collaborators in the bike class, corresponds with all the foreign keys that you need. Feel free to do so. Use tools as you best see fit. Cool. Oh, where's my? Oh, sorry. Use my iPad as my trackpad. And that resulted in that. Okay, last one. How do you decide with two very simple rated tables, students and photos, which table should have the link in it? So this would be based on the domain model that you have. And usually you think of like the hierarchy of your objects, like your tree of objects, and students will have many photos rather than each photo has many students. And if that's the case, if a student can have many photos, then the foreign key should lie in the photos table, and each photo should have a student ID attached to it. So it depends on how your domain model is set up. If a photo of a school photo, for example, had loads of students in it, then it will make sense the way around, where a photo would have loads of, where a student would have a photo ID rather than a photo of a student ID. You can imagine that scenario where over the course of a child's life, they're involved in many school photos, and so they need different photo IDs. So again, it just derives from the domain model, depending on how it's set up. If you think about the association, does a student have many photos? And does a photo belong to a student? If that's the case, then the foreign key belongs in the photos table. Photo will have a student ID. Like so. Commonly, this is sometimes called like an assets table, where you can have loads of different photos for different models or different things that you need. So commonly in e-commerce, you have a bunch of products, different kinds of products, and photos of those products, and each product has multiple assets. And then you get variants of products and things like that. It gets confusing. Does that help answer that question?
So when you use the e-commerce example, would that be like on Amazon, you have multiple pictures of the one product from different angles?
Exactly.
Yeah.
Exactly.
Okay.
Exactly. So in that case, that would be rather than a student ID, you'd have a product ID. So imagine a product table has like ID 342 was a pair of shorts, and then you'd have multiple photos of that product. And sometimes it gets even more confusing because each product has variants, like you have pink shorts, red shorts, green shorts, size M, size green. Like it gets quite interesting. You get variants and you get photos of each of those variants. So you need join tables and whatnot. But at its simplest, a product table, each product has many assets or many photos. Cool. That's it for questions, folks. Any other thoughts or questions for this morning's session?
Will you be uploading this? Because I feel like I need to review the questions and answers again, so I understand exactly what.
Absolutely.
Yeah. Okay.
Yeah. Rather than just storing them on my laptop, the video files. Yeah. Yeah. Any other thoughts or questions? Awesome. Okay, so the rest of this afternoon is your time. You have your pairs, so you can either continue this exercise, play around with it, look at the suggested implementation, break it down, go back through it, or continue with the bookmark manager. I gave a few more definitions here. Schema migration, relationship, primary key and foreign key. And what we'll do on Thursday is do something similar, but we'll write out some short definitions. So feel free to think about them, research them. We'll have a look on Thursday to make sure we know what those are. And then we'll introduce the modeling workshop for our end of unit challenge. Otherwise, yeah, this afternoon, just keep going with this exercise or resume with Bookmark Manager. Sound good?
Just to flag up, I will almost certainly be late tomorrow. So if I don't know what the pairs are tomorrow, but if people who are there just want to pair off and I can work solo when I do turn up, that's fine.
Thanks for letting me know, or letting us. Cool. Everyone know what they're going to be doing for the next couple hours until 2-ish?
Yep.
Yeah, awesome. All right. Enjoy, folks, and see you tomorrow.
Good morning.
Still recording.